So this particular bite-sized RSE session is about code style, quality, and linting. So this session will introduce the importance of code style and linting in writing clean and consistent and maintainable code. A quick overview of what this session will look like. So normally I will talk for about another 15 minutes to introduce the topic, give some background and maybe some theory behind this. And then I'm going to hand over to Steve, who is going to take you through the practical activity where you will get to use some of the things that we talk to you in practice. This is live coding or live demonstrating session. So whatever you see Steve doing, he will share his screen. You are expected to follow if you like. You can also observe. Following what Steve is doing is optional, but it's highly recommended. Unfortunately, we have very limited time. We don't have time for any troubleshooting of setup or installation problems. You should have done the setup before coming to this session, and instructions have been emailed to you. We also have a shared notes document. So this is a Google document that I will ask Steve to put in the chat for you now. If you can please sign into that document, that would be very much appreciated so we can keep an eye on number. This document contains links, important links for this session, training material, slides, follow-up reading, and everything you might need for this session. You can bookmark this document. It will remain available to you after the session, so you can come back and look it up and read it again to refresh your knowledge if you so wish. You can take your notes there as well. This is collaborative document. You all can use it as you wish. We might use it to pass some information to you, maybe some code that you need to copy and paste if need be. Okay, so let's get into the code style, quality, and linting. So why are we teaching you this? What is the motivation? Why does it matter? Why are we all here? So the thing with software development, it's an inherently collaborative activity. Even if you are currently working alone on the project, you don't intend for anyone to read your code at the moment. It is highly likely that someone will actually look at your code in the future. So it is important that that code is readable and understandable as much as possible for the colleagues who are coming after you, but also for yourself a couple of months down the line. You want to be able to quickly look at your code and quickly refresh or grasp what it is that you were doing. Consistency is really important in this process. The more your code is consistent and uniform, it will help with quickly being able to read and understand the code. The thing is, everyone in a team has their own coding style. So some people prefer to use some coding style, other people prefer to use another one, and there are always some kind of discussions around this. It's important to agree as a team on a uniform style that you're all going to use and share. So it helps readability and maintainability, as we will see later on how. And also it will help you when switching between projects. So if you adopt one set of coding style and guidelines, and you switch to another project that also uses the similar set of guidelines, then you already have the knowledge needed to quickly get up to speed with that project. Even if they use different coding style guidelines, you will understand the importance of it, and you'll be able to quickly learn a new set of guidelines and switch to that. And as I said, it really is vital when you are part of a team, because it helps everyone have a shared understanding of the code base. So what are the key code style practices and conventions? Well, they vary between programming languages, because all programming languages have different syntax, and then they all have their style practices and conventions. So these conventions cover a wide variety of things. So for example, aspects like line length, how long do you want your coding line to be? How do you split your line, or how do you split your code blocks? How do you use white space? Do you use one blank space? Do you use two blank spaces? Things like naming conventions for variables. Do you use in lowercase naming convention? Do you use underscores or dashes to split the words within a name of a variable, function, or a class? Or do you use perhaps camel case and so on? Indentation of your code blocks, commenting style, and so on. So quite a range of things. Like I said, programmers have very different views about styling. So if you talk to two different programmers, they probably won't have the same opinion on a style. But that's why we adopt these conventions and guidelines, so you can kind of unify them as much as possible. For example, there is loads of debate about what should be the maximum length of a line. So back in the old days, when we had slightly older hardware and we had limitations based on the terminals we were using, the maximum line length was set to 80 characters for readability. Now many coders think that that's too limiting, that that's too short, and because we all have slightly better screens or higher resolutions, we can show longer line lengths easily, that this is too limiting and that it should actually be changed or increased. Whichever convention you decide to go, it doesn't really matter. It's important that you define one for your project, for your team, and then you stick to it. Like I said, there are many established practices and guidelines and conventions for tailored for different programming languages. You might have heard about PEP 8 for Python. And because we use Python, you will probably hear us mention it more often. Also, there is a Google style guide for Python as well for you to have a look at, and other programming languages will have their own. So if you're not coding in Python, or that this is not your main language, please make sure that you maybe look up some code style practices and conventions for your programming language. So how can actually code style help us maintain the code quality, and how can it actually reduce bugs? So you might think, well, code quality, surely it can't help us reduce bugs, because even if our code is in terms of formatting and style all over the place, surely if it's syntactically correct and if it produces correct results, it doesn't really matter that it's maybe not consistently formatted. However, poor coding style can lead to some unexpected bugs and also can lead to maintenance issues. So some examples where coding styles can actually cause issues is, for example, if you're using unused variables, modules, or headers, so you're importing stuff that you don't actually use, those kind of things can clutter your code. And then it can also take longer for people who are reading your code to understand why these are being imported. So sometimes they have to go and dig deeper into the code to realize, well, these are not actually being used anywhere. But then they've already lost the valuable time. Things like using vague variable names, for example, using the name data all over the place to indicate different data sets, for example, might make it unclear which data variable you're actually handling and can cause you mistakes. Or again, it can take you longer to understand what's actually happening and which data you're dealing with. Things like bad indentation can actually cause logic errors. So, for example, running a code block when you don't intend it to run. So for languages like Python, which rely on indentation to define code blocks, this is really important because these kind of errors can happen and happen quite often. For languages that use delimiters like curly braces for code blocks, well, this is potentially reduced. These kind of errors are potentially reduced. And then there is loads of other issues like variable scoping or redefinition problems. So you're reusing the same variable name, but you're reusing it in different scopes, perhaps in a local scope and in a global scope, and that can lead to problems like shadowing, where a local variable can hide or redefine a global variable or a variable which comes from outer scope. Okay, so we know that adopting some of these guidelines will help us, but what other tooling is available to help us with being a bit more consistent with formatting and styling our code. There are tools that are called linters, and they're really, really useful tools. So what do they do? So linters perform static analysis of code. That means that you run the linter over your code base. It looks at your source code, at all of your files within your project, which can be big or grow bigger over time. They don't actually run the code, and they don't undertake any runtime analysis. So they're purely run before you actually try to execute and run your code. And they're meant to highlight or pinpoint either styling issues or some potential logical errors in your code, even before you run your code for the first time. So they're very, very useful because they get you to sort out problems at the very root. So it doesn't, the errors don't propagate through your code base over a long period of time. So they check your code for potential errors or the existence of statements that might lead to future bugs or unused variables or unused imported libraries and so on. And then they, like I said, they help catch these errors early and then enforce consistent code style, making your code more reliable and more correct and easier to maintain. The name linting comes from a late 1970s tool, which is called a linter. And it was chosen because of an analogy to the tiny bits of fiber and fluff shed by clothing, which are called lints. And then they are caught in a lint trap in a dryer. So this is the analogy. You're trying to catch these tiny little errors before they cause some bigger issues for you. And then there is a wide variety of these tools for different programming languages. Because we are talking about Python, even for Python, there is quite a few of them. So for example, you might have heard of Flake 8, which checks for compliance with PEP 8 coding convention, if that's what you want to stick with. You've got PyLint, which we are going to use today, which performs style checking along with some additional linting functionalities. You've got Bandit, which focuses on detecting potential security vulnerabilities in your code. Okay, so we are now ready to go into the practical activity to put into practice some of these things that I've just talked about and that I've introduced. So I'm going to hand over to Steve to take you through the practical part of this session. I'm going to stop sharing.
Right, thank you, Alex. Thank you for that great introduction. I'm just going to share my screen. Apologies, this might take a little while for me to click all the buttons I need to press to see what's going on. Once I share my screen, it all seems to go to pop for some reason. Right, okay, almost there. Right, okay, so does that look clear, Alex? Can you see that screen? Okay, great.
That's all good.
Good stuff. Right, okay, so what are we going to be doing today? Well, unsurprisingly, we're going to be looking at using a tool called Pylint, as Alex has introduced, which is a Python tool. And what it does is it examines code readability and styling issues for Pythonic code. Now, yesterday, for those of you who attended our session on integrated development environments, you may remember that we looked at some example code, and the example code we will look at today is perhaps unsurprisingly going to look very familiar to you. Because we'll be looking at more or less the same code. We explored some of the features of IDEs in this session to help write better code, including how they highlight issues in our code. So in this session, we're going to be taking it a step further by using Pylint to look at our code in more depth by doing a more in-depth analysis, right? So I should also point out that you do not need to have attended yesterday's session at all. You'll still be able to follow along, hopefully with no issues at all. But it does hopefully serve as a follow-along kind of session to what we did yesterday as well. So yes, what I'll be doing is I'll be demonstrating this via live coding. So I'm going to be sharing my screen, presenting a demonstration. You're free to code along with me if you want to, or you can just watch if you wish. It's up to you. What we're going to be doing is we're going to be using an editor of your choice, which could be VS Code, could be Nano, it could be Notepad, could be anything you like. We're also going to be providing an existing template repository for you to use for this activity that contains some code we're going to play with. And you'll also need Python installed as well, version 3.8 or above, strongly recommended. So a quick question. So using the Zoom's React capability, you should see a little React button on the bottom. Maybe you've used it before. How many are going to be participating in the live coding activity? Just give us a yes if you're going to be doing that, just so I can get an idea of numbers for who's going to be doing that. So if you give us a reaction there, using Zoom's React capability. So it looks like about 10 so far. Right, 11, 12, 13. Okay, 14. Okay. Right, so it's about 15 people. Okay, that sounds great. Thanks for doing that. We're going to use this capability throughout just to check progress as well. So, keep your trigger fingers ready to let me know how things are going when I ask you how things are going with something we've done. So, the live coding activity is only a taster. There's always going to be more to learn. Alex has already provided a Google Doc link for you to sign in, which also provides links to all this further information and also guides and signposting for learning about this topic further. As we said, unfortunately, due to time constraints, we're unlikely to be able to solve any in-depth technical issues you may have. But if you do run into issues, hopefully even as a demonstration, it should give you a taster on how to use linters to check your code, and it will hopefully be useful to you. Right, so what are we gonna cover today? So we're first going to clone an example template repository using Git and look at that Python code. We're also going to introduce the concept of what's known as a virtual environment and create one to hold some dependencies for the code that we're going to be looking at. So a virtual environment is a key technique in Python for managing dependencies on a per project basis. And it's one of those things that basically developers in Python and many other languages use on a daily basis. Very much a well-established technique. And it's available in many different modern languages, and also some of the older ones too, which we'll go into. And yeah, it's generally very useful for keeping your dependencies tidy for a project. So we're going to have a look at that. We're also going to install Pylint as well into that virtual environment. And then we're going to use Pylint to identify some issues with our code. We're then going to fix some issues that have been identified by running Pylint. And then once we fix those issues, we're going to use Pylint to verify that we fixed those issues correctly. And we're also going to look at some other more advanced features that Pylint gives us as well further on down the line. Okay, right. So with that, what I'm going to do is I'm just going to change a few things around on my screen. So if you bear with me, that would be great. Okay. Right. Right, actually, what I'll do is I don't need that anymore. Let's just get rid of that. So let's begin. So for this lesson, we're going to be using some example code on GitHub, which we're going to clone onto our machines using the bash shell. So firstly, what you need to do is open a bash shell. Now, if you're running on a Mac or Linux, you can bring up a terminal window, and then you should have access to bash there. If you have Windows, then if you'd follow the instructions that we sent out, hopefully you have git bash installed on your machines, and you can run git bash at this point to bring up a terminal. And so once you've been able to bring up a terminal, and here's one I prepared earlier, which hopefully you should be able to see. Can you see that, Alex, that terminal? Just want to check that.
Yep.
Brilliant. Okay, thank you. Cheers. So if you've managed to get to that point, if you could give us, if you could do a reaction, which is the green tick box, that would be great. If you have not been able to do that, just give us a red cross instead as a reaction. So it looks like people are sort of doing this, which is great. I know it takes a little time sometimes to run these, particularly on older machines. I think running git bash on Windows can take a while if you have an older machine. Okay, so it looks like you've been able to get that working. That's great. So what we need to do now is to clone this code onto our machine. So we need to pick a location to do that. So what I'd like you to do is to navigate to a location somewhere on your machine that you want this code to reside. I'm just going to put it in my home directory. So in git bash, if I do cd, which stands for change directory and return, that means I end up in my home directory. Okay. So what I'm going to do now is I'm going to ask you to type in a command, which is to clone that repository. So I'm just going to copy this into the chat. There we go. And you should be able to either copy that or copy and paste it into your terminal. So for me, I can do the Mac copy, Mac and the C key to copy that, and then I can do the Mac and the V key to paste it into my terminal. Okay, so once you've done that, press return. So yeah, there we go. So we've got git clone and the location of this repository in GitHub. So we now should be able to clone this onto our machines. And if you've got to this point, if you could give us a green tick box, that would be great. So I'll give you a little while just to give you some time to do that. If you have been unable to do that, please feel free to put any problems that you've encountered into the chat and give us a red reaction. That's absolutely fine. You know, sometimes these things happen. Looks like most of you have got there, I think. So yeah, okay. Can you clone it through your ID if you wish to do so? That's entirely up to you. I will say there's one caveat to that though, if you want to do it through PyCharm, is that you're already familiar with setting up virtual environments in PyCharm. That's probably my recommendation there. We won't have time to cover that in PyCharm. Oh, you are, so yeah, that's fine. So yes, feel free to go ahead and do it that way. If you've already used virtual environments, yes, that's absolutely fine. Otherwise, if you've managed to get to this point, great. Okay, so what we're going to do is we're going to continue, and we're going to do that. What we're going to do next is we're going to go into that directory. So cd space code style example. For those of you who saw that text appear very quickly, what I did is type in code, then press tab, which auto completed the rest of that that directory name for me automatically. So you should be able to do the same, or you can type it in manually. It's up to you. And then you should find that you're in this directory here with a couple of files. Okay. Right. Okay. So what we're going to do now is we're going to examine the code. So next, you can basically open this directory or these files in an editor of your choice. It's entirely up to you. I'm going to use Visual Studio Code because for presentation purposes, it makes it a little easier to see what's going on. But you could do this using nano. So if you're using git bash, you could do nano space climate analysis.py if you wish to do so, and then press return. And if you do that, you should see this pop up. Okay. And that's fine. You can use that if you're familiar with nano, that's fine. So I'm going to exit that by doing Windows X or Control X on Linux, and then get out of that. Sorry, that's Control X, I should say, to exit nano. I'm going to open it in VS Code. And the way I'm going to do that in VS Code is to click on the File Explorer icon, click on Open Folder. So this is the File Explorer. Click on Open Folder. Then click on the directory that we cloned earlier from GitHub. Click on Open, and I see something like this. Okay. Now, so I need to make this window a little bigger to close this. All right. So this is slightly annoying. I don't want that there at the moment. Right. I'm just gonna. I want to make sure I've got as much screen real estate to this as possible. So if you've been able to open this up in an editor, give us a green tick mark, or if you haven't, a red one. Okay, again, any editor of your choice is fine. These early stages always take a little bit of time, but once we get going, you should find that we speed up pretty quickly. Okay. Right, so if you haven't been able to do that or have a problem, please feel free to let us know by putting an X there instead. A red X is fine, and giving us an idea of the problem in the chat, and we'll help you as we can. Okay, right, so good stuff. It looks like you're just about there. So what we can do is we can take a quick look at this code now. So I'm going to click on this file here, climateanalysis.py. Okay, right, now the code is designed that we're looking at here is basically to process temperature data from a separate data file. A few things to note about this. It reads in data line by line from the data file and prints out Fahrenheit temperatures in both Celsius and Kelvin. So it does a little conversion from the input Fahrenheit temperature and into Kelvin and Celsius, and outputs that data to the output. If a line starts with a hash symbol, it ignores the line because it assumes it's a comment. And it defines and uses two functions to do these temperature conversions. Okay, one called far to Celsius and another to far to Kelvin. Okay, Now, for the purposes of the lesson, the code is deliberately written to contain some issues, and we're going to go into these throughout the session. Okay. Now, the code expects to find the data file in a particular location, okay, and that is in the data directory, right? So in the data directory, there's another file called SC climate data 10.csv, and the file will read this in, the Python script file will read this in line by line and do these conversions on a particular field in this data. Okay, now this data is arranged using comma separated value. So each line basically is a row of data, and each value in the row is separated by a comma. Okay, so in this case, what we're doing is I think we're taking the 1, 2, 3, 4. I think it's the min temp July F field, and that's the one that's actually being converted into Celsius and Kelvin. Okay, by our climate analysis.py file, which we have here. Okay, right. So, okay, now we've had a quick look at the code. We've had a look at the data that's going to be read in by this code. Before we run it, let's have a quick think about why we should write readable code. Now, Alex has given us some great motivations, but what I'd like to do is to ask you some questions. So, give us a green tick if you have ever seen or used code that looks something like this, or perhaps even worse. At any point in your career. I'm going to put my hand up twice. I typically work with code that looks in all kinds of shapes and sizes, basically. Okay. Okay. Now I'm going to ask you another question. Right? Don't be shy. Don't be shy. Who has written code like this? I'm putting my hand up twice again. I've definitely written code that is what I would say not perfect. Okay, I don't think I know anyone that writes good code all the time, right? It's next to impossible. And there's a number of reasons for that. Sometimes you need to explore ideas with code to understand how it's going to be designed. And this typically involves trying things out first. But the key is that once you understand how to do something, it's a good idea to make sure it's readable and understandable by other people, as Alex has said. And that, of course, can include a future version of yourself. Okay, so 6 months into the future, you come back to code, and you've written in a particular style that's perhaps inconsistent or doesn't use meaningful variable names. It can truly take a lot longer to understand stuff that you've written yourself. And if you've been writing a lot of code in the interim, that can really compound this and make it a lot more difficult to remember what it was you wrote. So it's really helpful to end up with good, clean code so it's easier to understand. I think a golden rule that I use is that someone mentioned in the code, my code is like that at the moment. Yes, I know the feeling. I too have code that looks a bit like this at the moment as well. So yeah, a golden rule I have found that I've held true to that has really helped me is I always assume that someone else is going to read my code in the future. Someone else could be myself 6 months in the future. It could be someone else entirely, another physical being who needs to understand my code. Perhaps they want to reuse it or extend it, modify it or fix it or something. So I always assume that's going to happen. The other thing I always assume is that someone's going to want to run it at some point as well. And if they're going to run the code, we need to make sure that it's something that is going to work properly. Okay, so that's something we're going to look at further along the line in this bite-sized RSE set of sessions. Now, another key benefit to writing cleaner code is that it's generally easier to extend and otherwise modify in the future. Okay, so when code's initially written, it's often impossible to tell it's going to be reused some way in the future. A familiar scenario is that you stop developing a piece of code for a while and you put it to one side, right? And maybe you focus on writing a research paper or a presentation or something. Or maybe it's just not needed anymore. Or perhaps a project is finished. There are so many reasons. And you forget about it until suddenly there's a need to use the code again. Maybe all of it needs to be reused in another project, or maybe just a part of it. However, you come back to your code and it's a mess you can't understand. And this comes back to the point, that it's a good idea to invest a little bit of time now to write good code while you understand it. So you can save yourself and others a lot of time later. And trust me, coming back to code that's more complicated than this, that is not particularly readable, is something that could consume a lot of time. On a related note, has anyone heard of a phrase called code smells? If anyone's heard of that phrase before, please feel free to let us know. Give us a green tick if you've heard it, or a red X if you haven't. Some may have come into contact with it. So okay, so whenever you've come across a piece of code, right, that you haven't seen before, has anyone come across code when you've just taken a quick glance at it and it's giving you a reason to not to trust the code in some way? You don't always know why specifically, but you think, I don't like the feel of this code. It's giving me indications, or it's giving me an odd set of vibes or smells, perhaps, that that it's not actually something that's up to scratch and isn't going to do your job. You can't always say why. You haven't looked at it in depth. I've certainly come across code that's been like that. And perhaps future in your career, you'll come across code that looks the same as well. Now, code smells are cursory indications from looking at the source code that a piece of code may have some deeper issues. And looking at the code, you can smell pretty bad depending on what code you're looking at. And so in this code, we can see, for example, there's inconsistent spacing. It's got lines bunched together in some places, and it looks very spread out in others. And this can typically make you feel that you don't have a great deal of confidence the code's going to work as you expect. And it can raise the question, if the style of the code appears rushed, what else has been rushed? What about the design of the code? Is it going to give us accurate results? Is it something I can trust with the data I want to give to the code? So it's something to bear in mind, that having clean code can help make the code easier to understand, but also can convey a greater degree of confidence. If your code is impeccably, works fine and always will give you the right result, but doesn't look particularly tidy, that can engender sort of a feeling that, perhaps it isn't that way, even though it might actually be absolutely fine in how it works. So it's something to think about. Presentation does actually matter. Right. Okay. So what we're going to do now is we're going to run this example code. So if you go back to your command lines, if you type in Python, and if you're on a Mac, that might actually be Python 3 you need to type in, and then type climate_analysis.py, or you can use code completion. And what we're going to do is we're going to run the code and just check that it works as we think it should work. And you should see something that looks like that. So if you manage to get to this state in the code, could you give us a green tick or a red cross if that's not something you see? I'll give you a little while just to type that in. Okay, right. So it looks like you've pretty much all managed to run that. That's looking good. Okay. Now we can see that the code does appear to work. We can see these Celsius and Kelvin values being outputted to the terminal. But we've already identified these issues of the readability. So how can we make that a little easier to read? Well, now we're going to use this linting tool to do exactly that, called PyLint. Okay. So what we're going to do now is we're going to install this linter. Okay. This is PyLint's a very well-established tool for statically analyzing Python code, but there are many others that Alex has also covered. Now, fortunately, PyLint can be installed as a Python package, so we don't need to install it as an operating system level package. We can just install it basically as something that's Python. And we're going to create what's known as a virtual environment to hold this packaged installation of PyLint. So I'd just like to know, because I think this is an interesting one, who's installed a Python package before at any point using the program pip. So let's see. If you haven't, don't be shy. That's fine. Everyone has to do something for the first time at some point. So okay, right, yeah. Vast majority of you, pretty much everybody. Okay, right. So yes, 18 of you have done that. 19, sorry. Okay, right. So the other question I'm going to ask is, who's created and used a Python virtual environment before? Okay, so a lot of you have, but some of you haven't. Okay, that's absolutely fine. So this is all about what it is. We're here to learn. So a virtual environment is something that's particularly useful, an incredibly well-established mechanism which we use on a day-to-day basis when we're doing programming. So they're really indispensable, and they help us to manage package dependencies across multiple projects. And to be honest, this could be a whole topic itself. In the case of Python, the idea is that instead of installing Python packages at the level of our machine's Python installation, which we could do, we're going to install them within their own kind of container of packages, which is separate to the machine's Python installation. And then we'll run our Python code only using packages within that virtual environment. And you may ask, well, why would we want to do that? Well, the really interesting thing here, and something that's particularly useful, is it creates a clear separation between the packages we use for the project and the packages we use for other projects. So this means that we don't end up with a machine's Python installation containing a clutter of 1,000 different packages, where determining packages that are used for particular projects becomes very time consuming and something that's very, very difficult and error prone. So since we are sure what our code actually needs as dependencies, it becomes much easier for someone else, which again could be a future version of ourselves, to know what these dependencies are and to be able to install them to use our code. Okay. Right, so the other thing is virtual environments are not limited to Python. For example, there are similar tools available for Ruby, Java, and JavaScript. And another really cool part of this one other important benefit of using virtual environments is that we can install different versions of the same package in different environments. So if we need to test a particular code with different versions of the same Python package, we could create two separate virtual environments, each with different sets of versions of the same packages, for example, and then test our code using both versions independently. Okay. So yes, lots of advantages. So what we're going to do is we're going to set up a virtual environment of our own. So what we'll do is we'll do that now. So I'm going to type in Python 3 -m, which is short for invoking a Python module. And the module we're going to invoke within Python is called venv, which is short for virtual environment. And I'm going to I need to give a name to my virtual environment, and that's going to be venv, okay? And that's going to be a directory that will contain this virtual environment packages for us, okay? So I'm just going to press return on that. So on some, if you're on Mac, it's Python 3 there that you may need to use. On Linux or Windows, it may just be Python, okay? Okay, so now we've created this virtual environment, we need to do something called activating it, okay? And we do that by typing in something like the following. Now, it's slightly different. Annoyingly, it's slightly different depending on which machine, which operating system you're running. I'm going to put this into the chat. So if you're on Linux or Mac, it's this source venv bin activate. Okay, and if you do that, fingers crossed, you should find you get a change in your prompt that looks a bit like that. Okay, now a common question we get asked is, well, why is it called venv? Why have we called it venv? Well, there's a number of conventions around using virtual environments, and one of those is that you call it something that is recognizable as a virtual environment. Okay, so you don't confuse it with the rest of the code base. Okay, so typically these could be .venv, .env, or venv, or something along those lines. So a developer looking at that would be able to see, okay, right, that's a virtual environment. Okay, it's not part of the core code base, but it contains the packages it's going to use. Right. The other thing is, if you're on Windows, you should see that you, instead of doing what I've done here, you do venv and then scripts and activate instead. Okay. Right. I won't do that obviously because it won't work on my machine, but hopefully it'll work on yours. Right. So let's see how people are doing. Who's been able to activate their virtual environment and have a prompt that has something that looks a bit like this at the start of it? Okay. All right. So yes, green ticks, if you can just let us know if that's something that's working for you, great. Red ticks if red crosses, I should say, if not. Right. Okay, good stuff. So what we'll do now is just do a quick look at the virtual environment and see what's there. If we do pip list, we can see on my machine, I only have one package currently installed, so it's effectively empty. The package is pip, which is our Python installation package manager. You may find you have another one called setup tools. It depends on the platform you're running. And sometimes I think to the version of Python you have as to whether you see one or two packages. But to all intents and purposes, that's an empty virtual environment. So what we want to do is make use of Pylint. So what we're going to do is we're going to install that now. Okay. The other thing I should point out is that this code doesn't need any other packages. If it did, for example, it was using some other package such as pandas or matplotlib or something along those lines, we could install those packages here. But as we know, this code can run without any other external packages. So We don't need to install anything else to get it to run. But what we do want to do is run Pylint, and that can be installed as a package into this virtual environment. So Pylint's a tool that can be run from the command line or via IDEs like VS Code, which can help our code in many different ways. So it can help ensure our code is consistent in style by verifying our code gets established coding guidelines like PEP 8, helps us stay consistent with these code style standards as well. And so it can also interestingly perform basic error detection. Even though this is not running our code, Pylint does have some capability to identify certain types of Python errors. Okay, so it can point these out for us as well. The other thing it does is it checks variable naming conventions. So Pylint often goes beyond PEP 8 to include other conventions, such as naming variables outside of functions, for example, in uppercase, right? And also it has a high degree of customization. So you can specify which errors and conventions you wish to check for and those you wish to ignore, which we'll look at later. So what we're going to do now, now that we have our Python virtual environment installed, is we're going to do pip install Pylint. And if you type that and press return, you should see a number of packages, which are packages that are used by Pylint to be installed, that also installs Pylint as well. Okay, so hopefully you should see something that looks like that. It probably won't look exactly the same. So if you've been able to get to that state, give us a green tick mark, and if not, give us a red one, and let us know what the problem is in the chat. Give you a second to do that. Now, it could be the packages you have look a little different to the ones I have. Again, it depends on the version of Python you have as to which version of Pylint's being installed and what dependencies it uses. Okay. Virtual environments are one of those things that are just so important that we felt it was good to cover that here. Okay. So I see that a few of you have been able, most of you have been able to do that, which is great. So, right. The other thing we can do is we can deactivate our virtual environment as well. So we can do deactivate, and then that brings us back to our global Python installation. So we've deactivated our virtual environment, and now we've gone back to our global Python installation. But we can reactivate our oops, what am I doing? We can reactivate our virtual environment by running this command again that we did earlier. Oops.
Source, the source command.
Source. Getting a little ahead of myself there. Thank you. So yes, source VM bin activate. Okay. And with Windows, of course, that would be the command you typed in earlier. So what we're going to do now is we're going to run Pylint. So I'm just going to clear my screen for clarity and type Pylint climate _ analysis.py. Okay, and it's going to go away and it's going to analyze our code. So a question being asked is, do I have to upgrade pip every time I create a VM? The answer is, strictly speaking, no. It sometimes recommends you do, and that message can be a little bit annoying. So I know some people that will always upgrade pip every single time that they create a virtual environment. You can do that if you wish. 99% of the time, it's not going to have any bearing on what you're doing, okay, to be honest. But yeah, it's entirely up to you. So Pylint climate _ analysis.py, and you should see a whole host of issues which perhaps quite unsurprisingly are being shown to us from Pylint's output. Okay. Right. And the other thing you will notice is we have this list of issues, which is telling us here, which we'll go into in a minute, but it's also giving us a score at the bottom, right? An overall score, okay, which is interesting. And you can see that it's given us this score 0.59 out of 10, which isn't great, is it? To be honest, let's be honest, that's not fantastic. Okay, we could do better. Okay, but we'll go into that in a minute. But for each issue, it tells us the file name. So we can point it at a directory, for example, and it can go and have a look at that directory's contents and subdirectories and tell us a whole host of files if we wanted to. But it tells us the particular file that it's found an issue, the line number and the text column the problem occurred, an issue identifier, which is this one here, which is basically a code that identifies what issue it is, and also a textual description of what that issue represents. Okay. Now, for the score, essentially for every infraction it finds, it deducts from an ideal score of 10. So note that it's perfectly possible to get a negative score. So since it just keeps deducting from 10, right? It's not supposed to be an all-seeing, all-dancing way of comparing the quality of your code with something else, but it's there as a way to sort of give you a motivation to improve your code by improving your score, right? But yeah, here it's pretty low. Okay. Now, if we were to resolve each of these issues in turn, theoretically, we should get a perfect score. Okay. So what we're going to do now is I'm just going to check to see that everyone's been able to run Pylint. So if you have, give us a thumbs up. If you haven't been able to do that, give us a red cross. Okay. Right, excellent. So if you've been able to run Pylint and get output look like that, I'm very happy. So that looks like 16 of you. So what we're going to do now is we're going to identify and fix a specific issue. And this could form part of our sort of cycle of what we would do. Run Pylint, identify issues, and basically try and fix them. Okay, so we can ask for more information on an issue if we wish. Okay, so for example, we can see at line 9 near column 35, there's a trailing white space. If I show you here, I'll put my cursor at the end, you'll notice that there it is. So line 9, there's a space right at the end there, okay? And that's a very minor one, but it's been identified, okay? And what we can do, excuse me, is we can ask Pylint for a little more information on that message, okay? So we can do Pylint help message C0303, which is the identifier for that particular issue that's found, and it gives a little more sort of helpful information. So it tells us it's used when there's white space between the end of a line and the new line, and it tells you that this message belongs to the format checker part of Pylint. Okay, so it's a little more specific on what's actually happening there. So if we need help clarifying a particular message, we can use this capability to give us that. Okay. So yes, we can find that there is this issue here, and we can now remove that space at the end of line 9, save the file. So I go VS Code to File and then Save. Okay. And then once I've done that, I can use the up arrow to get to Pylint climate analysis.py again and rerun that. And we should see that C0303 message should not be there anymore. And indeed, it's disappeared. Okay, so we fixed that issue. And we can see that our score's gone up a little bit now. It's not an absolutely blazingly terrible 0.59 out of 10, but it's now a pretty still awful 1.18 out of 10. Okay, so it is a little better. Okay, we see we're climbing up the ranks, as it were, in the scoring. Okay, right. So it can get quite addictive actually to increasing your score, which I guess is kind of the point. All right. So I found myself, doing this as a means to improve some code that I found. And yeah, you can go down a rabbit hole, and it teaches you all kinds of things. That process of what it means to write, reasonably good, well-structured code by looking at all these messages that pop up. And also, if you want to give one of your colleagues a shock, run Pylint on their code and point them at the results. Okay. The other thing we can do is we can look at what all of this actually means, right? So here we see its identifier as C0325, right? Now, what do the C? We also see there's another one here, which is a W, and there's an R there as well. Now, what do all these mean? What do these prefix symbols mean? Well, Pylint actually tells us a little bit about that. So if we do Pylint -long-help and then press return, right? I'm going to wait a minute just so everybody can see that. I'm actually going to put this into the chat, because this is going to scroll right off my screen. Okay, so I'm going to press return. Okay, so when we do long help, it tells us absolutely everything about what Pylint supports in terms of all the possible options we can give to it. There are a variety of different reports we can generate, ways we can change how the results are displayed, how in-depth the analysis should be, how it logs, all kinds of things. But at the very, very bottom, what it does is it tells us the 5 kinds of message types. Okay, so ones that are prefixed with an I are for info. These are informational messages. Okay, it's not something that's critical. It's just something it's basically drawing your attention to. C is a convention or a programming standards violation. So part of the code is not conforming to normally accepted conventions of writing good code, things like variable or function namings. R is for a need to refactor. Okay, and that can be due to a bad code smell, right? Something that indicates that the code has some problem with it. It could be that the code is all, has way too many lines in a single file. It could be that, I don't know, there's many different ways in which it could be that, it needs to be refactored. You have a big long file full of hundreds of functions. Maybe it's a good idea to separate that out into different files. Okay. A W could be for a warning, something that isn't critical that should be resolved, and E is for an error. So Pilot thinks it's spotted a bug. I wouldn't ever depend on that to find errors in code, but if you're lucky, it might sort of help you find one or two of them. And F would be that Pilot itself has run into a fatal Pilot error. Perhaps you pointed it at a file that wasn't Python, or perhaps at a non-existent file or something like that. And if we actually have a look, if we use the up arrow again to get to Pilot climate analysis.py and press return, we can actually see that nearly all of our infractions are to do with coding conventions. Okay, so most of these are code styling issues. They're not errors, they're not needs to refactor so much. There is one there, okay, but they're mostly code styling issues. Okay. So if you've been able to fix your code and rerun Pilot, if you give us a quick tick there or a red cross if you haven't been able to do that, that'd be great. Okay, I kind of left that checkpoint there, didn't I? I should have done it earlier. But yeah, if you've been able to get to that point, just let us know. Okay, great. So what we're going to do now is we're going to look at some of the more advanced features that linting gives us. Okay, now I mentioned earlier that linting is one of those things that you can use to find out, obviously, issues in your code, and Pilot gives us a number of different ways of analyzing that analysis. Okay, and what we're looking at the moment is the short form of that, but there's a way of looking at this in far more detail. And if we do Pilot with a -- reports yes argument, but run it over the same file like this. Right, I'm just going to put this into the chat just in case it floats off the top. Right, then what it does is it shows us this information, but in a more tabular form, okay, and gives us a lot more information, okay. So I'm going to start by looking at, where is it? This one here. So all those messages we saw before have now been grouped, so we can see how many occurrences of each type there are, which is really useful if we're looking at a huge code base to get an idea of the kinds of problems there are with a code base. So one thing that's really useful, if you ever come across a piece of code you're thinking of using somewhere on the internet, somewhere on GitHub, and you want to get an idea of, just an idea mind, an indication of what the code is like, you could run Pilot over the entire code base, and it will give you this kind of breakdown, right, of the kinds of issues that exist over the code. And by using this reports output, it really does help to sort of give that summary a little more weight. So we can see here that the main, if we have a look at this, we can see there's a number of aspects that have been, that can be identified in this report, as well as giving us this grouping on the number of occurrences for each of those different issues, all right? It tells us how many modules, classes, methods, and functions were looked at. Here we go. We can see there was one module, there were no classes or methods, and there were two functions that we have in our code that were examined. It gives us some raw metrics, which we'll look at in a minute. And it also gives us the extent of code duplication as well, which shows us there is no code duplication, which is good. And that could be a code smell, particularly, right? If you come across someone's code that has a lot of copy and paste, of code sitting across the code base, that can be an indication that perhaps things aren't all great. Okay, because if there's one problem that's going to exist in one code duplication fragment of code, it may not have been fixed in other locations, and maybe it's only been fixed in one or none at all, right? So code duplication can give us all kinds of issues. And it also gives us a number of messages by category, as we've said, and also a sorted count of the messages we have received. So just to clarify, this is a sorted list. So it's telling us the most numerous issues are at the top. Now, looking at the raw metrics, if we go back and have a look at that, it's telling us that it breaks down our program to how many code lines there are, Python doc strings, standalone comments, empty lines, and it's very useful. It gives us an idea of how well commented our code is. And in this case, we can see not very well commented at all. So for normal comments, the usually accepted wisdom is to add them to explain why you're doing something, or perhaps to explain how necessarily complex code works, but not to explain the obvious, okay? So well-written code should explain itself, but sometimes you need to add comments to explain it in more detail. What percentage of comments do you aim for? That's a great question. I think I've seen it said, there's a number of different percentages I've seen, anywhere from 20 to 40%, okay? In typical research software code, I tend to focus my code commenting to the bits that are particularly tricky to understand and the bits where I need to explain that rationale. So if you're doing some kind of simulation code in particular, or something that's doing some processing, right, I usually tend to focus my commenting in that part of the code base, because that's really where people, including yourself, need to understand what's happening. So wherever your code is most complex, that's where the comments should be. In terms of a strict percentage, yeah, that could be anything. It depends. My usual advice is, if you're not sure, give your code to someone else and see if they can understand it. And where they don't understand it, either think about changing the code to make it clearer, and or adding comments to explain what's going on and why you're doing it. The why is particularly important. Sometimes you put in code to get around a bug that exists in a library, and people say, well, why have you put that in there? And they take it out, not knowing why it was in there in the first place. And of course, the code then yields incorrect results, right? But you need to make the comment that this portion of code is needed, because otherwise it won't work properly, and that stops people then taking it out. I've come across that a number of times when I've needed to comment code that looks utterly bizarre, but is needed because something's not, otherwise it won't work properly, okay? So that's a really good indicator that you should write a comment. Okay, great. I'm glad that was helpful. So what we're going to do now is we're going to increase our pilot score, and this is where it can get a little bit addictive, right? So it's a little bit of gamification going on here with this score. So a quick question: who's familiar with Python doc strings? Now, anyone who attended our session yesterday, I suspect, could probably say they have a passing familiarity with doc strings, but perhaps you've seen them in other locations. So a green tick if you've heard or have seen or indeed written Python doc strings. Okay, so most of you have, some of you haven't, that's fine. So doc strings are a special kind of comment for a function or a Python module, basically that explains what that portion of code does, whether it's a function or a module. It covers what it attempts to achieve, the parameters it expects as arguments, what it's going to be returned from the function. And so yes, you can also write doc strings for classes, methods, and modules, but you should usually aim to add docstring comments to your code wherever you can, particularly for critical or complex functions. Okay, so let's add one to our code now within our far2Celsius function. Okay, so we've got this function far2Celsius, and there's no commenting at all in this code. What we're going to do is we're going to write this thing called a docstring. Okay, and you can do that just by starting the docstring with what's known as a multi-line comment, right, which is double quote, double quote, double quote, right? And if you press return, you might find if you have if you're doing this in VS Code, you might find that it's generating the docstring for you, which is fine because you attended yesterday's session. But if not, you can just type 3 double quotes and 3 double quotes. That's the beginning and the end of our docstring. But what we can do is we can type in what this function is trying to do. So convert Fahrenheit to Celsius. Now, as I said before, one of the really useful things to do is to comment your code, or write it so it's clear as you're kind of writing it, right? So that it's clear for you to understand and others further on down the line, and whilst it's still fresh in your head, right? And writing docstrings is one of those things that just gets to be a habit if you do it enough, and you just do it automatically once you finish writing a function. Now I'm going to use, there are different styles of doc strings. So I'm just going to put something into the chat for those that are interested, which goes into detail about the different styles of doc strings. Okay, there's several different types. There was one we looked at yesterday, which is, let me see. I always get these styles mixed around because there's so many of them. Which one was it? Which style? So, okay. I think what we were doing was closest to a Google style of docstring there. But the one we're going to look at now is a slightly different one, which is Sphinx style. Okay, so the Sphinx style of doing doc strings, and the important thing is just to pick one that's suitable for your project and be consistent. Okay, this is one of my favorite ones. So I'm just going to put in what the arguments are into this function, and the first parameter is far that goes into this function, and this is our temperature in Fahrenheit. Okay, can't spell Fahrenheit most of the time. So that's the argument that comes in, and also it returns a temperature in Celsius, right, as you would expect. Okay, now obviously with more complex functions, this is something that can be invaluable to understand how these parameters are used, what they're for, what the function is attempting to do, and you can add more or less detail depending on how much you need to explain. Okay, so now that we've done that, what we can do is we can save our file. Oops, no, I didn't mean to do that. File, my cursor's too big. File save, there we go. Okay, so I've just saved that file. So if you go ahead and make the change and save the file, then let's just see if you've been able to do that. So if you've been able to add a doc string to your code, you're happy with that. You can write anything you like, it doesn't really matter. Yeah, just give us a green tick there, that would be really helpful. Okay, right, looks like most of you got to that point. So what we can do now is we can run pylint over our code again. So pylint, let's see, climate analysis.py, press return. And we can see now our code's been rated slightly higher, 1.76. And the issue that was highlighted, there was a missing doc string for the far to Celsius function is no longer there. Okay, so there are some other issues with far to Celsius, of course, but the fact we have a missing doc string is not one of them, and our score's gone up slightly. Right. Okay. So the other thing we can do is we can get Pylint to ignore issues as well. Okay. So if we're looking at a large code base and perhaps there's a wealth of issues, and to be honest, there's just too many to try and easily be able to understand, we can ask Pylint to disable its checking for various issues. So if you have a look at our list of issues here, you can see there's one which is a warning W0621, which is redefining name Kelvin from outer scope. Now, perhaps we don't want to see that particular issue, and what we can do is we can disable that one entirely by doing pylint -- disable equals W0611, and then space, run it over climate analysis.py again, press return. Right, and that issue will not actually now
On the
present
wrong
itself.
number of the
Thank you. Well spotted, Alex. You really are on the ball. Excellent. Thank you so much. Let's pick, yes, 0621. Let's try that one. Oh, we've had a little more success with that one. Okay, thank you, Alex. So we can see now that, yes, those issues are not now being reported. And we can also disable all warnings if we want to do that. So I'm going to press up on my keyboard, go back to this and just do disable equals W, press return, and then we'll see that we're disabling all of those, all warnings in their entirety. So we can disable different classes if we wish to do that. If we wish to, for example, not to look at any of the code contravention infractions, we could disable all of those by doing disable equals C, and that just gives us the warning and the refactoring messages in this case. Right. Okay, so what we're going to do next is we're going to edit our climate analysis.py file and add in a comment line that exceeds 100 characters. Okay, and And we're going to do this to deliberately invoke an issue with our code. So it doesn't matter what you write in the file. I'm just going to write anything, but I'm going to make sure it's over 100 characters. That's probably over 100 characters. Okay. So if you do that, add it into your code and then just save the file again. So I could use a shortcut there by doing Mac key and S at the same time, but I'm doing it using the menus, but you can save it using the keyboard shortcut if you wish instead. Okay, and then what we're going to do is we're going to rerun Pylint and determine the issue identifier for the message. Okay, so I'm going to just do Pylint climate analysis. And let's see if we find that. Okay, so here we go. We can see that we've contravened a code convention issue, which is lines too long. It's 145 characters over 100. So if you've been able to break that that infraction, if you give us a tick, that would be great. I think some of you have already done it. I'm just going to, yes, brilliant. Okay, looks like nearly all of you have done that. That's excellent. Right, okay, so naughty us, we've introduced an issue. Right, okay. So we can see the identifier is C0301, and of course, if I go up on my arrow keys, go through my history of previous commands, we can type in disable equals C0301, oops, and then press return. Okay, all right, so we've disabled that now, okay? So we're no longer looking for that particular message, right? But if we wanted to do that every single time, we would have to put that disable message in there. Now, why would you want to do that? Well, that's because line too long messages, as Alex has said, can be a little bit too constraining, particularly if you have big monitors, okay? And to be fair, I typically see code lines in excess of 100, right? In big code bases quite often. And it doesn't actually detract from the readability if you have a large monitor, which most people seem to do. And if that's suitable for your project and you think 100 characters is fine, or even 120 characters is fine, you know, perhaps this is something you want to consistently ignore. And what you can do, you can actually tell Pylint to disable these warnings on a permanent basis. Okay, and we're going to do that now. Okay, so what we'll do is we're going to use Pylint to generate what's known as its own RC file, right? It's a resource file, basically a resource configuration file. And we do that by typing in Pylint --generate -RC file. And we're going to do something called redirection to redirect that output to a file which is called pylint.pylintrc. So I've used the bigger than here in bash to basically take the output from this command, and it's going to put it into this file .pylintrc, okay, in the root directory of our code repository. Okay, so if you press return on that, you'll see absolutely nothing, right? But what it's done is it's generated its default configuration file in this directory. Now, if you go to an editor and click on it or open it in whatever editor you like, you'll see you have this pre-generated file here. So if you've been able to do that, thanks for copying that in, Alex, to the chat. If you've been able to do that, if you could give us a green tick, I'm just going to clear the feedback. Sorry, yes, now if you could let us know if you've been able to do that and open the file. Great, okay, looks like most of you have been able to do that. So what we're going to do is we're going to permanently disable this C0301 message. So what we're going to do is we're going to search for the disable equals. Now, it depends which editor you're using, but I'm just going to search for it and tell you the line number so you can cheat. So I'm going to do the Mac F key for find in VS Code. It might differ. It would probably differ on your whatever editor you're using. Oops, what am I doing? I'm looking for disable equals, right? And there it is. Okay, so you should find it on about or around line 439. And these effectively are all of the conventions that are currently not going to be reported on, okay? So what we're going to do is we're going to add in, let's just add in C0301 at the top of those, like this, something like that. Okay, so I've just put C0301 just after disable there, a comma, and then pressed return. So now we've added it to this list of things that are going to be ignored. Now, if you save that file, okay, and then rerun it, but this time without the disable that we had before, you should see that it doesn't appear at all. Okay, so we've permanently disabled that message for this particular project. Okay. So that can be really helpful if, as a team, we decide particular messages are just getting in the way of us understanding the Pylint output and are not particularly useful. We can elect as a team, or if we're just working on ourselves, we think they're just annoying, we can just turn them off by creating this Pylint.rc file, disabling them. And there's a whole host of other things we can change in terms of the behavior of Pylint that's beyond the scope of this session, but feel free to take a look at the documentation and it will explain all the different options you have there, and there are a great many. Okay, right. So who's been able to edit that Pylint.rc file, rerun it, and hopefully they've seen that it's not included that warning message. Okay. Right. So if you haven't been able to do that, let us know any issues you've had in the chat. Right, so the last thing I wanted to cover briefly is just for the benefit of those that attended yesterday when we were looking at VS Code, is you may be delighted to know, or perhaps mildly interested to know, that what you can do is you can add an extension to VS Code which is essentially Pylint, to do this Pylinting. All right, so I'm going to click on the extensions icon there for VS Code. Okay, this allows us to add some functionality to VS Code in some way. Okay, and I'm going to search for Pylint. Okay, and it should be the top hit with 2.8 million downloads there. If you then type that in at the top, it should appear, and then if you click install, hopefully it won't take too long to install. It should then be installed. It says okay, disable or uninstall. So okay, it's been installed, no problem. Now if I go back to my code, no, that's not my code, this is my code, we should see a whole load of squiggly underlines of various colors. Okay, suddenly appear in our code. Okay, and this is now giving us a kind of a real-time view of the linting warnings within our code, within VS Code. So if you're working within an IDE such as PyCharm or VS Code, you can basically configure it to do this, so it can give you this kind of real-time feedback, which is really handy. Okay. Okay, so here, for example, if we hover over import string, it's basically saying missing a module doc string. There's an unused import string here. So we've typed this in, but we're not actually using the string library at all. So we should just remove it. Okay, so that's telling us one thing. If we hover over shift equals 3, it's telling us that shift is really a constant and should conform to uppercase naming style. So what we should do with that one, so let's get rid of these. Just as an example, let's get rid of that and put this into uppercase like that. We should see that the error then disappears. If we resave, you can see that it's disappeared. Right, okay, so who's been able to install, for those of you that have VS Code, who's been able to install that Pylint extension successfully? May not be many of you, depending on how many of you were here yesterday. And of course, some of you, of course, may be using VS Code anyway. Okay, so 8 of you. Okay, good. Hopefully that's useful to you. So if you happen not to see any squiggly lines suddenly appear in the editor, it could be the linter extension hasn't looked at your code yet. Sometimes it needs a little bit of a push to actually begin its analysis of your code in real time. So in order to trigger the linter to show us these issues, what you can do is you can try saving the file to trigger the linter to have a look at it. So if you go to File, then Save on the menu bar, you should now see, hopefully, the squiggly lines appear in the code. Hopefully, Lois, that helps you, helps that issue that you're facing. Fingers crossed. Okay, right. So these squiggly lines are indicating all these issues. We can see just by hovering over them what they actually mean, which is really helpful. Okay. And so, yes, if we want to see a comprehensive list of all the issues found, similarly to how we were doing this with running Pilot on the command line, if we go to view, right, in VS Code, again, this is for those in VS Code, and then go to problems, you'll have all of these basically listed out here in this pane at the bottom, and you can click on those, and it will just basically take you to those locations. Okay, which is really handy if you want to see these things, you know, one by one and deal with them in turn. Okay, right. So code linters. So in summary, then, code linters like Pilot help us to identify problems in our code, all these code styling issues, potential errors, and importantly, if we work in a team of developers, such tools help us keep our code consistent across our team. And one of the problems that you tend to find when working in teams is assumption is what tends to introduce problems into code bases. People assuming how things work. And one way to get rid of assumptions is to, or at least some of them, is to make your code consistent. It's far harder to make assumptions about how code's working if all looks pretty much the same and uses the same kind of coding style. Okay, it at least increases the chance that it won't be misinterpreted or you know, false assumptions will be made. Okay, if it's more readable, it's easier to understand. Making it consistent means that everyone is writing the same code and reading the same code. But there are some aspects we should be careful of when using linters and interpreting their results. It does not tell us the code actually works, and they don't tell us if the results produced are actually correct. So we should still need to test our code. And we actually have a session on testing of code coming up next week. If you're interested, as part of this series of bite-sized RSE sessions. They don't give us any idea of whether it's a good implementation and that the technical choices are good ones. Okay, it can highlight some issues with the code, but it won't tell us if the choices we're making behind the scenes for, you know, which libraries we're using or the implementations we're making are good choices. Okay, so for example, this code contains functions to conduct temperature conversions, but it turns out there's a number of well-maintained Python packages that do this already, such as PyTemperature. So we should be using a tried and tested package instead of reinventing the wheel all the time. They also don't tell us if the implementation is actually fit for purpose. So it could be an absolutely rock solid implementation, well implemented, good technical choices, works as expected, but does it actually solve the intended problem? So again, you know, thinking about what the purpose of a piece of code is incredibly important. They also don't tell us anything about the data the program uses, which may have its own problems. If we're using bad data, there's an old phrase which is garbage in, garbage out for computers. If you're using bad data, doesn't matter how good your code is, you know, it's only going to be generating results based on bad data, and the results will be bad. Okay. Now, the other thing is a high score or 0 warnings may give us false confidence. Okay, it's something to bear in mind. If we manage to reach a 10 out of 10 score, it doesn't mean the code is actually good. It says it's likely well formatted and hopefully easier to read and understand, but it can still be bad code. There's still ways to get around what Pilot tells us. So we do have to be a bit careful. And, you know, these are all valid high-level questions to ask when you're writing code, both to the team and also to ourselves. And in the fog of development, it can be surprisingly easy to lose track of what's actually being implemented and how it's being implemented. So a good idea is to revisit these questions regularly to be sure you can answer them. But, you know, taking these shortcomings into account, linters are a very low effort way to help us improve our code and keep it consistent. We can run this over our code. It, you know, it happens very, very quickly. And if we do this on a regular basis, it's taking a very small amount of our time to highlight issues that we should perhaps consider fixing. Okay. And again, you know, if we're fixing problems earlier, that's always better than fixing them later.